All right, ladies and gentlemen, hopefully you got to know your partner a little bit better, and hopefully you will get to do those activities after finals week. Let's move into number one. Number one, if you were asked to simplify this and there was an answer on the Scantron that said x squared minus 4, would you choose it?
No.
No, why not?
Because you have to do FOIL.
Nice. We have to multiply it by itself and FOIL. So we would do first times first, which gives us x squared. Outside gives us negative 2x. Inside gives us negative 2x. Last gives us positive 4. And then are there any like terms I can combine? Good. The middle two, which gives me x squared minus 4x plus 4. Number two is a repeat, so I'm not going to do that one. But number three, do we know how to simplify this? What process should I use? FOIL again, but this one's a little bit different because what is x squared times x? Good, x cubed. And then outside would give us negative 4x squared. Inside would give us positive 1x. And last would give us negative 4. Are there any like terms there? No, so that would be it.
Is that the order?
That's the order it would stay in because that's standard form, highest degree to lowest. Okay, number 4 is a repeat, so I'm going to jump to number 5 through 14 really. It says, factor the following if possible, if not possible, write prime. What would be the first step in all of factoring? GCF. Now, if you tend to forget that, that's something you could write on your note card. Step 1, look for GCF. I sometimes forget that, so that would probably be a reminder to me. Then, looking at number 5, out of those two terms, what would be the GCF? 3x, good. And if you'd like to, you could actually show dividing both sides or both terms by 3x, because that's what factoring is. And that would leave me with 5x plus what? Good, 1. Any number divided by itself is 1. And that would be my answer. That's it. Number 6. Number 6, is there a GCF? No, so we're going to jump to our 2 parentheses. The last term is negative, so are we going to have same or different signs? Different. If you didn't remember that, that's something you could write on your note card. John, West, and Peter, this is going to be your last warning, okay? I'm going to change your guys' seats if you're too distracting. Okay, the last term's negative, so we know we're going to have different signs. Then I undo the F in FOIL. So what times what would give me x squared? Good, x and x. Then you undo the L. What times what gives you 6? 2 and 3. If I tried 2 and 3, how do I know if it works? OI it. If I OI this, do I get negative 5x? No, I would get negative x. If I switch them, that would just give me a positive x. So what do I need to do? Yeah, get rid of them and choose 6 and 1. And if I make the 6 negative and the 1 positive, does that add up to negative 5x? Yep, and so I box it. Good question. So if this was, I'll say if it was equal to 0, the directions would say solve, and then that would be our clue of I need to actually get x by itself. All right, on to number 7 is a slight bit different. So let's go ahead and do number 7. Number 7, is there a GCF? Nope, so we'll jump to the parentheses again. The last term's negative, so we know we're gonna have different signs. Then if I undo the F, what times what gives me 2x squared? 2x and x, and then if I undo the L, what times what gives me 7? 7 and 1, if I put the 7 here and the 1 here, if I OI it, it will give me 7x minus 2x. It'll give me a positive 5x. What do you do if just the sign is the opposite of what you want? Switch the signs. If I make this negative into a positive, and I make this positive into a negative, now it will add up to be a negative 5x. So that's just kind of a key helpful reminder. Number 8 is very much like number 7, so I'm going to jump to number 9. Number 9, how do I factor if I have 4 terms? Good, the 2 different groups. So I'll group the first 2 and the last 2. Take out the GCF. What's the GCF of the first 2? Good, x squared. And what will that leave me with? X plus 6, good. What do I copy to the other side? X plus 6, awesome. I can't change that original, so I have to ask what times x would maintain a negative 2x? Close. Negative 2, and I can check it. Negative 2 times 6 will produce a negative 12. Now, out of these 2, what would be the GCF? Good, x plus 6. Oh, I pressed something, I'll change it. So I take that out, and that would be x plus 6 times quantity x squared minus 2. It doesn't matter. And actually, that's a good question. On the final, it is Scantron, so you might be given this as x squared minus 2 times x plus 6 instead. And you have to recognize that's the same thing. So just be careful with that. Okay, what one was that one? The next one's very similar to it. So let's jump down to number 11. Number 11, x squared minus 64. This is one of those rules that we learned. I'm going to do a little thought bubble because it might be good to put on your note card if you don't remember it. What is the rule that matches a squared minus b squared? It factors down into what? Okay, so you guys just know the answer, which is great. So I would maybe not write the rule, but the rule, if you didn't know it, it factors down to a minus b times a plus b. So if you're like, I don't remember what to do with this type, this is the rule you're looking for. But then you do have to know what is being representative of a. And you guys told me that would be x because we have x squared. And the value that's being representative of b would be 8 because that's 8 squared. So this is going to factor down into x minus 8 times quantity x plus 8. Nope. Could be x plus 8, x minus 8. Ah, good question. So let's actually use Mario's question to jump down to number 13. Number 13. What does this factor down into? Okay, so what did the directions say to do if it's not factorable? If not possible, write prime. This is like the number 11. Well, if I told you factor the number 11, you'd be like, you're crazy. It's prime because it's not factorable. X squared plus 4, the difference is the plus sign. So you do want to make note that that rule only works for the difference of 2 squares. If you were thinking, well, why isn't it x plus 2 times x plus 2? If you FOIL that, you'll get x squared plus 4x plus 4. So the reason that this works is because when you do the outside and the inside, it cancels. 8x plus negative 8x is 0. But a plus sign, we have nothing that will multiply back to be that. Okay, number 12, is that the same as number 11? No, what's different, Zinnia?
Oh, wait, so if it's a subtraction, then
If it's a subtraction with 2 squares,
yeah,
or if it's a subtraction with 2 cubes,
yes.
you can factor. But if it's an addition with 2 squares, you can't factor. And if it's an addition with 2 cubes, you can.
Okay, got it.
Yes, this is the SOAP. So the rule, if you didn't remember the rule, or this is something that would be helpful to you to write on your note card, a cubed minus b cubed factors down into quantity a minus b times a squared plus ab plus b squared. Mario?
So on our note card, so say we get right numbers. So what if we did like x, x cubed minus like a represents some sort of number?
X cubed minus a,
Yeah.
and
Instead
you,
of 8, because you said the table.
well, that would technically be like this. You would just be using x instead of a.
So we can write.
You can write this. This is something you can write on your note card because this has variables. I just don't really want to see any numbers.
I was saying as in like, for me to like remember like, oh, like to use that formula for x cubed. Like,
So if you wanted to say like,
oh, I see, okay, I see what you're saying.
You could do like that, if that helps you remember better than just an A.
Okay.
That's a good thing to do. And then guys, we use that SOAP formula because or SOAP acronym, because if you have A cubed plus B cubed, it's almost the exact same formula. The A's and the B's are the exact same. So if you're trying to save space on your note card, if you can remember just SOAP to help you remember the signs, you might not have to rewrite all of that. Because how do the signs differ? If it's a plus sign, what does the S represent in SOAP? Same, so then it's going to be plus. What does the O represent? Opposite, and what's the AP? Always positive. Okay, so those are the two rules you will need to know for the final. Weston. Then it's going to be this rule. So these are really the two rules that you need to know, and you'll be using the second rule for number 14. Zinnia. Yeah, you can write the word so. Yeah, I'm basically going to be looking for variables and vocabulary. So that's like English words I'm okay with. But numbers you can't have because
Shucks, I was gonna-
you could, and I'd probably be okay with it.
Really? They're wrote Russian?
I mean, no, because you could write out the number 4, and I don't know that you're writing the number 4, so don't write in Russian. English words, yeah. Okay, so this, then we need to know, you can't write out numbers. I'm gonna be looking for numbers. Don't write out numbers. If you're gonna use a coding, if you're gonna go through that much trouble, I don't know. I'll talk to you about it after the final. English words,
Might as well.
English
just-
words. You guys
Can we
are
write out the
silly.
Full thing, or does it just have to be so?
You can write out the full thing. Yeah. All right, guys, let's get back on track. What is being cubed here to give you X cubed? Well, that gives you 8, good. And then what gives you X cubed would be X. So this would factor down into X minus 2 times quantity X squared plus 2X plus 2 squared, which would simplify to 4. And that would be my answer. Moving right along, we finished the factoring piece. If it said solve, and we're actually going to see that tomorrow. If it said solve this, then we would have to actually take this, set each equal to 0, and find the actual answers for X. But that's the difference. These instructions said factor and there was no equal sign. Those would say solve. And the nice thing about the final, guys, is it is Scantron. So I will most likely either have pieces like this or answers for X. And I'm not going to, it's multiple choice. Yeah. All right, let's move on to number 15. The Scantron, it's basically like ACT. So you'll have a paper that you can write all over, but your answer will need to get transferred to the Scantron. I will ask you to write your work. Here's why. I've had cases in the past where somebody did really bad on the final, and I was like, this is very atypical of them. Usually they do pretty good on assessments. So I went back through their packet, and because of their work, I was able to see that they actually lost track of the numbers and were circling the wrong thing. And I was able to give them back credit because I saw their work matched up. So I encourage you to put your work down. So in the off chance that you made some kind of slip up, I can go back and give you points. Freddie. Yes. Yep. Well, not all of them. The last one should stay positive. Number 15. Simplify the rational expression. Now, Caleb got excited about multiple choice, and I do like multiple choice, but I want to caution you. Like number 15, there will be an answer, something that might look like this: n squared over 2n cubed plus n squared. I know that a common mistake are people reduce the 3 here, and the 6 turns into a 2. Scantrons, like tests that are made, ACTs, they know the common mistakes and they will put that answer to try to trick you. So you do have to know your content. Why can I not reduce the 3 and the 6? Yes, the 6n cubed is a term. So if you don't remember that, I would put this as a note. You could write this on your note card because this is vocabulary. You only reduce factors. If you don't know what a factor is, I would say numbers that have been multiplied, not terms. Terms are something like this, anything that's been added or subtracted. So with that said, the question is, how do we then simplify this? And the key is factoring, because if you have a factor, you can reduce that. So the numerator, I can't really factor, but if I look at the denominator, what can I take out as a GCF? N squared, good. And I would take that out, and that would leave me with a 6n plus 1. And then I have 3n squared on the top. Now what can I reduce? The n squared, because they're being multiplied. Those are factors. So the n squared divided by itself gives me 1. And then my answer will be, in just a moment, my OneNote has frozen again. But it should be 3 over 6n plus 1. Magic. And there's... Hey, why? You were working fine. Sorry. This is
GCF, right?
the what?
GCF is in the denominator.
There's a we had to take that out, the n squared. Yeah, sorry, brief. Okay, low system resources. I don't know what that means. Yes.
Oh, yeah, but I think that
So it is a term as 1, but 3 and n squared are factors because they're being multiplied. So as one whole unit, it's a term. But if I look at the pieces of the term, the factors make up the term.
yeah.
6n cubed, but it makes up one term. A term is composed of factors. Yes. Let me get Caleb and then I'll get Mario. Caleb.
Okay, so like, I'm just like, it's been a while since I've been, so I'm kind of confused a little bit.
Okay.
But like, so you can't simplify like the actual numbers themselves, you can simplify the.
You could simplify the number if it didn't have anything added or subtracted to it. If I had something like this, then I could reduce the numbers. And this would be 1 over 2n. Yep. So basically, before you reduce, think they have to be multiplied. There cannot be any pluses or minuses next to it. Otherwise, they're glued together. Anything with plus and minus is glued as 1, unless you take out a GCF.
So if there was just 3n squared over 6n.
You could reduce the 3, the 6, and the n's because there's no pluses or minuses. Good question. All right, good stuff. Moving on to number 16. Number 16, we have a fraction divided by a fraction. How do you simplify if you have a fraction divided by a fraction? Freddie? Flip it. Awesome. If you didn't remember that, this is a way you could put this on your note card. You could say like a over b divided by c over d turns into a over b multiplied by d over c. That's kind of a way that you could write that in using variables to keep you as a reminder, hey, if I'm dividing, multiply by the reciprocal. So now I can see I have to multiply by x minus 5 over x plus 10. And then what do I have to do with this first fraction? Factor, good. So the last term's positive, which means I'm gonna have the same signs as the middle term. So plus and plus. Then x times x would give me x squared. What are factors of 20 that work here? 10 and 2, good. Can I factor x squared minus 4? Yeah, what does that factor down into? Good, x plus 2, x minus 2. Now I can reduce. Any number divided by itself is 1. I can reduce x plus 2 divided by x plus 2. Again, there's 2 terms making up the factor, but it is a factor because it's being multiplied. And then I can reduce the x plus 10 divided by x plus 10 is 1. And then as I multiply across, I'll have x minus 5 over x minus 2. Mario. This was lesson P7. Was it B or C? Oh, goodness. I think it's B. P7C is when we added and subtracted. So yes. All right, on to number 17. Number 17, if I multiply, am I going to flip that second fraction? No, but I do need to factor where possible. So if I look at the denominator of the first fraction, can we factor this? Yep, what does that factor into? Good, x minus 2x plus 2. Can I factor the second denominator?
Actually, no,
Why can't I? You're correct.
because it's up.
It's a plus sign, awesome. So this is gonna just stay as x squared plus 4. But now I can reduce. Any number divided by itself is 1. You might want to actually put the 1 there because it goes into itself one time. If you multiply across, this divided by itself will be 1. You might actually want to put the 1 there. When you multiply, what's left in the numerator? Good, 1, and then the denominator, good, it's going to become over x squared plus 4. All right, moving right along, number 18. In order to add and subtract, what do you need? A common denominator. What's the least common denominator between 2x and 7x? 14x, right? So what am I going to multiply this right fraction by?
14x/1.
Oh, that would be if it was an equation. Then I'd want to get rid of it. If I'm just adding, I'm going to multiply it by 2 over 2, and this one by 7 over 7. That will create 21 over 14x plus 2 over 14x. Now the denominators are the same, so I can combine the numerator, and that'll become 23 over 14x. And that would be my answer. Number 19. Yeah. Number 19, we need a common denominator again. What is the LCD? In fact, I want to see if you guys know this between you and your partner. Turn to your partner and the person with the most pets. I know we've done it before. The person with the most pets, you share what would be the least common denominator between x plus 1 and x plus 2?
X plus 1.
Olivia, that's you, right? Your 3 dogs?
Yeah, would it be x plus 1 multiplied by x plus 7?
Yes, you're amazing. Well done. All right, guys, let's see if you got it. It should be x plus 1 times x plus 2, which means I'm going to need to multiply, this by x plus 1 over x plus 1. And I'm gonna have to multiply this first one by x plus 2 over x plus 2. Sophie.
I was a little bit confused with this. So you multiply it by what you need to get to the denominator or by the denominator?
So if there's an equal sign, then you're going to multiply it by the least common denominator. There's no equal sign here, so I want to get. Yes, I want to get that. Good question. Okay, now I have that common denominator, x plus 1, x plus 2. And the next one is x plus 1, x plus 2. So I'm going to start combining the numerators, but I need to make sure I'm careful with that distributive property. I'd have to distribute this 1 to get x plus 2 back. If I'm subtracting, I'll have to distribute this 2, which will create 2x plus 2. Now I can combine the numerators, but here's the tricky part. What is secretly around 2x plus 2? There's nothing shown. The subtraction is there,
-1.
and -1 is there. And what am I going to have to do with -1? Distribute, because you are subtracting that entire second numerator. So yes, I'll have to distribute that here and here, which will now create x plus 2 minus 2x minus 2 all over that common denominator of x plus 1 times x plus 2. And now I'll combine like terms. X plus -2x gives me -x. What's 2 plus -2? 0, and then I have my answer, negative x over x plus 1 times x plus 2. Mario,
Why does it x plus 1
x plus 1 squared.
or
Oh, why don't we multiply? Well, we don't,
just cancel them or-
well, we don't need another x plus 1 over here. We just really need it over here to create a common denominator.
I'm saying at the bottom.
Oh, because you're oh, because it's like taking 5 over 6 minus 2 over 6. What would be your answer? 3 over 6. So you just want to keep that denominator. Don't multiply them. It would still become, it would be 7 over 6. If it was multiplication, now it would be over 6 squared. All right, moving on to number 20. Number 20, actually, I'm going to let you guys do that on your own. I think you all can solve that equation, but we did review it. Do keep in mind to distribute the 3. Don't do it now, though. We'll do it during free time. Let's move on to 21. 21A. This is a situation that Caleb was talking about. Now we have these denominators, but now it's an equal sign and I want to solve. So I want to get rid of all the fractions. And we learned how to do so in one nice step. What would we multiply both sides by to get rid of those 3x? Good, the LCD. So in this case, the least common denominator is 3x. So I'm going to multiply it by this side, and I'm going to distribute it to this side. So I have to multiply it by everything. Since I'm multiplying to a fraction, I'm going to put 3x over 1. Because when you multiply that in, you're really working with the number over 1. And the reason I do that is so I can reduce. 3x goes into itself one time. And so I'm left with 4 minus x goes into itself one time. So I have minus 3 times 2 is equal to 3x. Good. So now I continue working through this, and it's 4 minus 6 equals 3x. 4 minus 6 is negative 2. And then we divide both sides by 3. And we get x is equal to negative 2/3. On to number 22. Number 22 is now not only factor, but now we're given those instructions, solve by factoring. I think you could do this with your partner. So this time, the person with the least amount of pets, you turn to your partner and tell them, how would you go about solving this? That's me. Okay. So I would look for a GCF. There's none. So then I would factor that down. The last term's negative, so we know we're going to have different signs, plus and minus. If I undo the F, 2x times 3x would work. And then if I undo the L, if it's 2 and 1, I wouldn't put the 2 in with the 2x because there's no GCF to start with. So I try 2 here and the 1 here, but that would create negative 4x plus 3x. That would create a negative x. So Olivia, do you know what I do?
Yeah, you swap the signs.
And then now we have to go further because it said solve. So we set them each equal to 0.
Mhm.
And I would subtract 2, which gives me 3x equals negative 2. Divide by 3. And I get x is equal to negative 2/3.
Mhm.
And then if I set 2x minus 1 equal to 0, add 1, divide by 2, I'll get x is equal to 1/2.
Yep.
Nice. All right, guys, how did we do? If you factored correctly, you should have 2x minus 1 times 3x plus 2. Then this one, you have to set them each equal to 0 to actually solve. You should get x equals negative 2/3 and x equals 1/2. Okay. And one of the reasons I might have factored a little bit quicker is I remembered that if there's no GCF to start with, there's no GCF to end with. So that's how I knew not to put the 2 in with the 2x. So that told me put the 1 there, put the 2 in the other spot, and then that would help me factor it. All right, on to number 20. Wow, that's really bad typo, but hey, it helps us. We went from 22 to 26. Why that happened, I have no idea. Okay, so skipping 4 problems. Solve the equation using the quadratic formula. If you don't know the quadratic formula, or if it's something that you would like to put on the note card, here's what I would put down. I wouldn't just put x equals negative b, blah, 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 blah. I would put if ax squared plus bx plus c is equal to 0. That's an important step to be able to use the quadratic formula. Then I know that x is going to equal the opposite of b plus or minus square root of b squared minus 4 times ac all over 2 times a. And now I would use it. So number 26, do we know what a is? 2, I think some of us are already doing it. B is -3, C is -2. And then I put these pieces in. So x is equal to the opposite of b, the opposite of -3, plus or minus square root of b squared minus 4 times a, which is 2, times c, which is -2, all over 2 times a. As I simplify that, the opposite of -3 is 3, plus or minus square root of 9. What's a negative times a negative? Positive, good. So we're going to get plus 16 all over 4. That will simplify to square root of 25. Would I stop there? No, what can I do? Simplify the square root of 25, which will be 3 plus 5 over 4 and 3 minus 5 over 4. Would I stop there? No, keep going. What's 3 plus 5? 8. What's 8 divided by 4? 2. 3 minus 5 would give me -2. What does -2 divided by 4 reduce to? Yep. And those would be the answers I'd be looking for in the multiple choice. Yeah. Yeah. There will be usually 4 or 5 answers. Sometimes there's none of the above. So, oh, no, no, no. You can only circle 1. Yeah. I won't have 2 answers that are correct. Yeah. Katie. Yes. Yes. You'll write all over the test, and then you'll just make sure that your final answer gets bulleted on the Scantron. All right, guys, number 27, solve by completing the square. Let's see if we remember that process. Letter A is actually already set up for you to do so. So do you remember what to do with that number 6? Divide it by 2, and then do what with it? Square it. Weston. That's okay. Just make sure you subtract the 5 and go all the way through. And you want to be really careful because the answer usually reduces a lot in the quadratic formula versus the more simple ones to complete the square. But it will work as long as you do it fully correct. Okay, so we would add 9 and add 9. So our work becomes x squared plus 6x plus 9 equals 5 plus 9. 5 plus 9 is obviously 14. Why did we complete the square? What do we do with this now? Factor it. It's x plus 3 times x plus 3. How can I better write that? Good. So we have x plus 3 squared is equal to 14. Then what undoes a square? Square root. What do I need to keep in mind when taking a square root? Plus or minus. Nice. So I have x plus 3 equals plus or minus root 14. And what's the last thing I need to do? Minus the 3. Get x by itself. So my answer would be x is equal to -3 plus or minus square root of 14. That was lesson 1.4, I believe, either B or C. I can't remember exactly. I'm sorry. I think it was B. Zinnia.
For the final
Mhm.
notes, like solve like
It will. Yes, it'll tell you. All right, number 28. Iron Man and Captain America share a paper route. Their movies must not be doing very well. It takes Iron Man 17 minutes to deliver the papers, whereas Captain America takes 39 minutes. How long does it take them when they work together? Okay. We learned a formula that you could write on your note card that might be helpful. Essentially, you took someone's rate of work multiplied by how long they work, and then you added it to the other person's rate of work multiplied by how long they work, and they usually work on one job together.
So it's like 1 over the time of person A times the amount of time that they're working together plus 1 over the time of person B alone times.
Yes, very, very similar. So guys, here's a way I like to think about it. Let's say that it takes you 4 hours to clean your room. What would be your rate per hour? If it takes you 4 hours to clean your room, how much would you get done or what's your rate per hour? 1/4, 1 over 4. So that's how you identify someone's rate. It's 1 over the time it takes. I'm just going to call person A. So time it takes A to do the job alone. Yes, job equals rate times time. So this is your rate multiplied by the time A works on the job. So if you work 4 hours, you're going to get your whole room cleaned. But this is usually in the math world, we're looking for you have some type of help. So it would be 1 over the time it takes person B to do the job alone, multiplied by the time B works on the job, is going to equal the 1 job together. So Iron Man is faster at delivering papers than Captain America. Makes sense, he can fly. But he's getting Captain America's help. So should it take him more or less than 17 minutes? Should it take Iron Man more or less time than 17 minutes to do the job? Less, because he's getting help. So our answer should be less than 17 minutes, because if he works for 17 minutes, he's done the whole job. Okay, let's go in and let's put this in. So person A is Iron Man. How long does it take Iron Man to do the job by himself? 17 minutes. So his rate is 1/17. Multiplied by how long is Iron Man going to work on the job? X. We don't know. That's what we're trying to figure out. How long does it take him to do the job? Plus 1 over how long does it take Captain America to do the job alone? 39 minutes multiplied by how long is Captain America going to work on the job? X, the same amount of time as Iron Man works because they're working together, is going to equal the 1 job. Now from here, after the setup, you have to know how to solve mathematically. So X is the same as X over 1. And so this equation actually simplifies to X over 17 plus X over 39 is equal to 1. This was the whole rational equations lesson unit. How do we get rid of all those fractions? Least common denominator. So 17 and 39 are prime numbers. Is 39 prime? 39 is not prime, but 17 is prime. So we'd actually multiply by 17 times 39. It's big, but it's possible.
660.
I haven't done it yet because I want to do as much as I can without the calculator, but it does multiply into something. Now, before I multiply in, I reduce. 17 goes into itself 1 time. So that would be 39x plus 39 goes into itself 1 time. So we have 17x is equal to, now I have to multiply that out, and it is 663, I think. Yeah, that happens. And then you add these together and that will give you 50, thank you, 56x is equal to 663. Divide both sides by 56. and I would just write it as a decimal. The time that they work together is approximately 11.83 minutes. Does it make sense if it takes Iron Man 17 minutes by himself, that if he gets help, it'll take him about 12 minutes? Yeah, because he's getting help with someone that's slower than him. I mean, Captain America can walk, you know, he can definitely walk. That would work. That would work. All right, guys, 29 is much like 28, so we're going to end with number 30. Number 30, what? I would actually ask you to turn to your partner, solve this together. I think you guys could do this without any direction. So, Olivia, what would you do here?
You would add 9 to the other side,
Okay,
and then you would square root both sides.
good.
Then get you x equals 3 and x equals -3.
Nice, plus or minus 3. Well done. Awesome. All right, guys, the other way, my partner added 9, took the square root, and she remembered the plus or minus. If you typically forget the plus or minus, a different way you could have solved this is by factoring. And then you would still get x to equal 3 and x to equal -3. Doesn't matter really which way you solve, you just have to get to that correct answer. Okay, you guys have 30 minutes to work. I would suggest that you try the B's. This is really the homework due for Friday, but if you did not have the homework due today, again, you want to be working well to get both of those assignments completed. But I will turn on some Christmas music and you guys have some time